looking at questions number 21 and 24 from the Limits Practice 1, Chapter 2.1 in the Finney Demana textbook. So we're being asked to determine the limit graphically and then confirm algebraically. So 21, if we take a look at the graph at 21, it looks like this. Okay, so there's the graph of number 21, and it asks what is the limit as x approaches 1. So as x approaches 1, we're going to get this value right there. Okay, and that value looks like it's somewhere around, maybe 1/2 or something like that. Okay, so how am I going to figure this out algebraically? So I'm going to write out number 21 here. So the limit as x approaches 0, and I'm going to factor the numerator. It's going to be x plus 1, x minus 1. Okay, so that's going to be the denominator. The numerator is x minus 1. The denominator is x plus 1, x minus 1. And to evaluate this limit, what we do is algebraically cancel out that. This is x goes to 1. That is going to be the 0 divided by 0. That's canceling out. Now we can input our 1 into the expression, so we end up with 1/2. So the limit is 1/2. So in this case here, this value at that point is y equals 1/2. And that's how we establish the limit algebraically. We can do example 22 the same way. Example 22, we're looking at the limit as t approaches 2. So as t approaches 2, we're looking at some value right about there. Again, it looks like maybe it's about 1/4 or 1/2, somewhere in there. Okay. That's going to be that. If I plug in t equals 2 into number 22, I get 0 divided by 0. So this is a bit of a problem. So I want to evaluate that algebraically. I'm going to see if I can get rid of that divide by 0 algebraically. So we end up with t minus 3, t minus 1 in the numerator, in the denominator, t minus 3, so it's going to be minus 2 minus 1. And in the denominator, we end up with t minus 2, t plus 2. So these cancel out. There's when I plug in my 2, I get 0 over 0. That's really the problem that is happening here, is that's what's generating my 0 over 0. So if I plug in 2 into here, I ended up with 1 over 4. 2 plus 2 is 4, so the limit as t goes to 2 is equal to 1 over 4. And again, that would be where that point resides at x equals 2. Looks like the y value is about 1/4.